Welcome back. In this video, we're going to explore trigonometric cofunction identities. You see here I've got a triangle labeled with sides A, B, and C. And in trig, we'll label the sides opposite those angles with their lowercase corresponding letters. So across from angle A, lowercase a, across from angle B, lowercase b, and across from angle C is lowercase c. And we know from SOHCAHTOA, if we're going to work from angle A, and we're going to call angle A theta, some measure, this is just a Greek letter, it's like x. Because the sum of the interior angles of a triangle add up to 180 degrees, we've got 90 with our right angle. Theta takes up some number of degrees, then angle B is the complement of angle A, or also 90 minus theta. And if we refer to SOHCAHTOA, we know that the sine of theta, or the sine of angle A here in this case, SOHCAHTOA sine is the opposite over the hypotenuse. So the sine of theta is A over C. Well, looking at the complement of theta, or 90 minus theta, the cosine of 90 minus theta, or in this case angle B, is also A over C. So we can see from this generic example that the sine of an angle, A over C, is equal to the cosine of its complement. So we can see here that these are complementary angles. Okay, and they're equivalent. They have equivalent values. Their trig functions are equivalent. And we can do the same thing for tangent and secant. The tangent of theta is opposite over adjacent is A over B. Well, the cotangent of 90 minus theta is also A over B. So the cotangent is the reciprocal of the tangent. Okay? So if the tangent is opposite over adjacent, then our cotangent is the adjacent over the opposite. And the same works for secant. The secant of the angle theta, in this case, is C over B. Secant's the reciprocal of cosine. Cosine would be B over C, so the reciprocal is C over B, is equal to the cosecant of its complement. The cosecant of 90 minus theta is also C over B. So we see here that the sine of an angle, or the tangent of an angle, or the secant, is equal to the complement of its cofunction. So we could take a look at this with like a 3, 4, 5. The cosine of Q, of angle Q, is equal to 4 over 5. So the sine of angle P is also 4 over 5. So the sine of an angle equals the cosine of its complement. Or we could see the same thing with a 30, 60, 90. So if I work from the 60, the sine of 60 degrees, the sine of 60 is the opposite over the hypotenuse. It's the square root of 3 over 2. So the cosine of 30 degrees is adjacent over the hypotenuse. It is also the square root of 3 over 2. And we could do that for all of our trig functions if we chose to. So to give you some numerical examples, we're asked to write each function in terms of its cofunction. So the sine of 9 is equal to what? Well, its cofunction of sine, the cofunction of sine equals cosine. So the sine of 9 degrees equals the cosine of 90 minus 9, the cosine of its complement. So the sine of 9 degrees equals the cosine of 81 degrees. So the answer to that is cosine of 81. So the cotangent of 76 equals the tangent, because the tangent is the cofunction of the cotangent, of 90 minus 76. So the cotangent of 76 equals the tangent of 14. And the cosecant of 30, well, the cofunction of the cosecant is secant. So we take the complement of 30, and the cosecant of 30 degrees equals the secant of 60. You also might be able to do something like this. We want to find one solution for this equation. Assume all the angles are acute. So the cotangent of theta minus 8 equals the tangent of 4 theta plus 13. Well, cotangent and tangent are cofunctions. Okay, so in order for these to be equivalent, right, the cotangent of an angle has to equal the tangent of its complement. So we know that theta minus 8 and 4 theta plus 13 are complements, which means their sum is 90 degrees. So we can say theta minus 8 plus 4 theta plus 13 has to equal 90. We add our like terms. We know 4 theta plus theta is 5 theta. And we have a negative 8 plus 13. All I did is rewrite my like terms here. So we have 5 theta. 13 minus 8 is 5. 5 theta plus 5 equals 90. 5 theta equals 85. All I did was subtract 5 from both sides. Divided by 5. And theta is equal to 17. So that's the solution. We have solved for our unknown theta. And that's an introduction to trig cofunction identities. And with that, I will see you in class.